So the reason I'm making this video right here is because I think we have practiced too much on the hard stuff, and therefore students are missing the easy problems. For example, on the last quiz, and if you already went over this in my office with me, then just fast forward this part. But on the last quiz, one of the most missed things was finding the derivative of, hang on here, it's a little technical trouble. I should have a ddx in front of this. This was the first problem in the derivative section, and as part of the product rule, you needed to find the derivative of the natural log of radical x. Some of you just said 1 over 2 radical x, which is of course just the derivative of radical x. And the reason that this is so ironic, and I want to address this, is that look back at the quiz that the last quiz, okay? Look back at this and look at where we were doing logarithmic differentiation, and look how hard and complicated that problem was. Okay, and the same people that missed the easy problem were a lot of the same people who aced this really difficult problem. So we have to remember that if I give you a problem that's easier than it usually is, it's the same rules. Okay, we have to learn how to recognize the use of the same rules if the context is a little bit different, even if the context is easier, right? It's one thing to see a rule, I put it in harder context and you get confused. But what I'm seeing more than anything else is taking a rule that we've been practicing, putting it into an easier context, and that's where people are having a lot of trouble. So what you needed to do in this case is we have to remember our rules for natural log. Okay, radical x is x to the half. Okay, so you are being asked to find the derivative of the natural log of x to the half. And you know how to do that because you've been doing it on much harder problems than this. Okay, so we know if natural log's involved, we're allowed to drop the exponent in front. Okay, so that becomes 1/2 natural log x. Actually, I should still have the derivative, the ddx in front here because I've yet to take the derivative. Okay, I'm just rewriting. Okay, and then I get here and I say, well, what's the derivative of natural log of x? Okay, and we know that that is 1 over x. Okay, so it's just the 1 over 2 times the 1 over x that simplifies to 1 over 2x. Okay, so the derivative of natural log of x is 1 over x. I'm still having people having trouble here, right, with then the antiderivative of 1 over x or 1 over u, right, is the natural log of the absolute value of u. Some of you are still having trouble when you're getting to this point, remembering that. All right, so anyway, let's suppose I asked you to do logarithmic differentiation. Okay, so again, that is what was happening on this quiz. Logarithmic differentiation, we did it with this monstrosity of a problem. Okay, and we said, okay, if you take the natural log of both sides, okay, and then the derivative of the natural log of f of x is 1 over f of x with the derivative of f of x in the numerator. Okay, so that's how we find this derivative. And we take the natural log of both sides and we apply the rules, and then we solve for f prime of x. Okay, we practiced that on very difficult problems. So maybe on your final, I don't want you spending such a long time. You know, your final is only supposed to take you about an hour, hour and 15. Okay, it's the same size as a regular exam. So maybe I want to test you on logarithmic differentiation without giving you a terrible monstrosity of a problem. All right, logarithmic differentiation can be done on, well, actually, I can't fit the L in here, can I? It can be done on basically any problem that you want to apply it to. Okay, if I take the natural log of both sides, so say I'm taking the derivative of 1 over x. Okay, so I'm going to take the natural log of both sides. Now, I want you to remember, because again, one of my points is that we are struggling doing things that are too easy. Okay, so in this problem, I didn't give any directions and I should have. My goal is to find f prime of x. Okay, and without logarithmic differentiation, right, I hope you would recognize that this is x to the negative first and go from there. I'll address that way of doing it in a minute. Okay, because again, this should be an easy problem and we're having trouble with our easy problems. So let's focus on the logarithmic differentiation. Okay, so natural log of f of x, that is 1 over f of x, the reciprocal of f of x with the derivative of f of x in the numerator. Okay, so that's what we get on this side. And then on the other side, actually, hang on, I'm doing some poor mathematics because I took the derivative of the left-hand side. I'm not ready yet to take the derivative of the right-hand side. And I either take the derivative of both sides at once, or I haven't taken the derivative of either side yet. So let me come up here and get this ready for me to take the derivative. Okay, this is a quotient. All right, which means I can use that rule of natural logs, that the natural log of a divided by b is the natural log of a minus the natural log of b. Okay, you might recognize that the natural log of 1 is 0. Even if you didn't recognize that, the natural log of a number, okay, for example, the natural log of 2, the natural log of 3, anytime I have a number like this, the derivative of this is a constant, right? Natural log of 2 is a constant. Its derivative would be 0. It's not a half, right? Sometimes people think the derivative of natural log of 2 is a half, right? But it's a constant. So whether you recognize this as 0 or whether you recognize that natural log of any number is just a constant, its derivative is 0. Okay, so then we get, when we take the derivative of this side, we get 0 minus, well, what's the derivative of natural log of x? And that's 1 over x. Okay, but then what do I have to do? Right, what do I have to do next? I want to solve for f prime of x. So logarithmic differentiation says multiply both sides by f of x. All right, get rid of that f of x on the bottom so that all we have left is f prime of x. So I get f prime of x is equal to negative 1 over x. And then I say, well, what was f of x? What was f of x right up at the beginning of this problem? It was 1 over x. So in place of f of x, I put 1 over x. And my final answer is negative 1 over x squared. Okay, so I want to make it clear to you that logarithmic differentiation, although it's most necessary when we have to take the derivative of something awful, I could ask you to use logarithmic differentiation on the derivative of a function that's not terribly difficult. Okay, for example, we did use logarithmic differentiation when we wanted to find the derivative of exponential functions like this. As I've mentioned before, anytime you have an exponent problem, right, either literally or figuratively, you have a problem with an exponent, right, or you have a problem and it's with an exponent, right? So literally or figuratively, think natural log of both sides. Okay, and so we did use logarithmic differentiation on this to get to the derivative of our exponential functions, all right, by taking the natural log on both sides. So, you know, that's another place that I could ask you to do this, right? And again, it wouldn't be terribly difficult. Take the natural log of both sides. This x drops in front, right? We know this leads to this, and then you would go from there. So anyway, I just wanted to point out that this derivative of, when you're finding the derivative of x to the negative first, we've practiced so much with more complicated functions, with the trig, with the e, with the inverse trig, with natural log. It's been a long time since we've really just reviewed basic power rule. I mean, this was stuff we were doing like back in September. So again, I just wanted to make sure that we reviewed a little bit of the basics here together. So this derivative, remember, drop the exponent in front, decrease the power by 1, and I am going to write on the final that you are not allowed to leave negative exponents. That's been a rule all semester. So this comes back downstairs. And as you can see, I'd say doing it this way was a little bit easier than using logarithmic differentiation, but it could be done, right? And we could apply logarithmic differentiation to more examples than you might realize, right? We could apply them to some of the examples where I'm asking you to use the quotient rule and you decide, I'll just take the natural log of both sides and I'll use my log rules and I'll go from there. And you would get an equivalent answer that I would give you full credit for. So anyway, just a couple other things I want to review with just the basic power rule. And also, like this next example here, there's some work with fractions. Okay, and I was out supervising student teachers the other day, and one of my student teachers said to me, oh my gosh, my 8th graders panic when they see fractions. And I said, well, I have calculus students that still panic when they see fractions. Okay, so what we learned about fractions, any constant, back at the beginning of the year, I put a lot of emphasis on separating the expression, right? The constant from the variable. Okay, so I would separate off the 2/5, and then that's 2/5 times x to the -3rd. And by the way, the directions are find the derivative. I should always write directions, right? Find the derivative of this function. Okay, and then this next one is simply 9/10 times x. Okay, so how do we find the derivative of this? So we get to just kind of ignore the constants, okay, and then we're back to power rule. So remember what to do here, 1 over x cubed, bring it upstairs, and then I hope we remember how to multiply fractions, right? Because we have to multiply -3 times 2/5. Okay, so we only multiply, this is like 3 over 1, right? So sometimes students multiply numerator and denominator by 3, which is wrong, right? So that would be -6 over 5, and then decrease the power by 1, so that becomes x to the -4th. Okay, so we have to talk about how to, or review how to rewrite that. And then over here, we know the derivative of 3x is 3. We know the derivative of 10x is 10, right? So the derivative of 9/10 x, right, is just 9/10 because the derivative of x is 1. Okay, and so back to writing this first term in proper form, the x to the 4th comes downstairs, and there's already the 5 downstairs. Okay, so the x to the 4th can just sit downstairs right next to the 5. And we get this plus 9/10 as our final answer. Okay, so we can't forget just our basic power rule, okay, that we were doing way back at the very beginning. So same thing down here with this antiderivative. Okay, a lot of students just immediately start saying, oh, I've got to do u sub, right? All we ever do is u sub anymore. Don't forget there was a whole section where we were just using the power rule to find antiderivatives. So again, this comes upstairs as x to the -1/2. No u sub involved. If you find yourself just letting x be u, and you're just changing a variable from just x to u, then you really haven't done anything. The u sub wasn't necessary. Okay, so we get here, and then we increase the power by 1, divide by the new power, And this should make sense because what function has 1 over radical 2 as its derivative? Because here we get new power is 1/2, but then instead of dividing by the fraction, we multiply by the reciprocal. So multiply this by 2. And I gave you a definite integral this time. And so this should make sense to you because this is 2 radical x. We know the derivative of radical x is 1 over 2 radical x. Okay, so having a 2 here is why we have no 2 here, right? But the derivative of this gets me back to here. And then just plug in. Okay, and wasn't that nice of me? I gave you perfect squares. So you have 2 times 5 minus 2 times radical 4, which is 2. So 10 minus 4 is 6. Okay, so it might seem weird to have made a video of the easiest problems. But like I said, I was just concerned, you know, we've been working on so much challenging stuff, and I was just concerned people are going to miss the easy stuff because they're so focused on studying the hard things. So again, I hope this helped, and reach out if you have more questions.